Have you ever wondered how many times high school students buy chips in a week and how it affects their health? Have you ever thought of how long the average high school relationship lasts? How late is the average student in Mr. Anderson's third period statistics class? Stay tuned to find out the answers to these pressing questions on Against All Even.
High school relationships are unpredictable. With Valentine's Day just around the corner, couples are making up and breaking up. In fact, my own daughter is confused as to what to get her Valentine. But I have a more pressing question in mind. How long does the average high school relationship actually last? There's no way to say for sure exactly how long because there are so many couples out there, but we can find out through a confidence interval. A few videos ago, we learned about z-scores. Now, with the confidence interval, we can use the z-score to get a range of values in which we are relatively confident contains the true average. In this video, we'll also learn about trade-offs and sample sizes. Let's take a closer look at one high school, Monte Vista High School in Cupertino, California.
Monte Vista is located in the midst of the Silicon Valley, known for its vast technological advances. In this world of engineers and computer scientists, you might think romance would be out of place. However, each day at Monte Vista High School, couples begin and end relationships.
I've been in a relationship that lasted 1 month.
How did you feel about that?
I felt it was alright.
Oh, but then what happened?
We had our differences.
The school student advocate, Mr. Prinz, is doing research as to how long the average couple lasts.
So I've done a little research on this, and so looking at my research, in order to get an accurate idea of the average length of time of a relationship, I did an observational study of about 50 couples over a period of 4 years, and I obtained a mean duration for a relationship. After constructing a z-interval on the data, I'm about 95% confident that the true relationship length lies within 3.2 and 4.4 months.
In this example, we will use the z-interval to find a range for the true relationship length mean. Before we start, though, we must make sure that 3 conditions are fulfilled.
First, the data must be collected from a simple random sample. Each observation must be independent. Next, the distribution of the data must be normal. Lastly, we have to know the standard deviation of the population. The last condition is not reasonable, but we will learn a way to get around it in future videos. Now, let's take a closer look at the math. We will use a confidence level of 95%. The confidence level tells us how confident we are about the true mean being within a certain range. The higher the confidence level, the larger the range will be. We will assume a standard deviation of 1 month because we don't know the actual standard deviation of the population. In later videos, we will learn how to do the confidence intervals without knowing the population standard deviation, but for now we will just assume a value. The sample mean is the same as the mean of the population. To find the standard deviation of the sample, we use the formula standard deviation equals sigma over square root of n. Now we can replace these variables with our values. The standard deviation is 1 month and the sample size is 50. We get a standard deviation of 0.14 using the 68, 95, 99 rule. We know that there is a 95% probability that the true mean lies within 2 standard deviations, or 0.28, months of the sample mean. We can say that the margin of error is plus or minus 0.28 months. We use this margin of error to find the confidence interval by adding it to the sample mean to get the upper bound and subtracting it from the sample mean to get the lower bound. In this case, we get the range, or interval, from 3.52 to 4.08 with the confidence level of 95%. We now have a way to find how close we are to the true mean. The confidence interval is like a net that will catch the true mean for 95% of all samples taken.
We are 95% confident that the true mean of the relationship length is between 3.2 to 4.4 months, or we are 95% confident that the interval from 3.2 to 4.4 months captures the true mean value of the average high school relationship length.
Students have a wide array of food offered to them by the school cafeteria. Nutritionists are interested in finding out the average number of times a student buys chips per week at Monte Vista.
I buy chips at Monte Vista about once a week, maybe less on average. I buy chips because it kind of sucks, but they're a substitute for a meal and they're kind of cheap. So.
Previously, we used the 68, 95, 99 rule to find the margin of error with a 95% confidence level. What if we want a confidence level of 90%? Here's how we do it.
With 90% confidence level, we are left with 0.5 on each tail. The z-value that leaves that amount in the tail is called z-star. Because the area in the center is 0.9 and the left side tail is 0.05, the area to the left of z-star is 0.95. If we enter this value in the calculator, we get a z-star of 1.64. You can find z-star using inverse norm on your calculator. The general formula for the confidence interval is x bar plus or minus z-star times the standard deviation of the sample. Now we substitute in the values acquired from the research. We are 90% confident that the true mean of the number of bags of chips a student buys per week lies in the interval of 5 bags of chips plus or minus 4.47 bags of chips.
School attendance is something many seniors fall behind on during second semester. But how does this affect their performance? Researchers have conducted a study to find out the average number of times a student is absent from Mr. Anderson's statistics class.
Some days the students are more absent than others, and we decided to do some research and see what's going on, and we're going to study this further. We did a 95% confidence interval, and we found the margin of error to be about 6% using a z-interval in this case.
When performing confidence intervals, we have certain trade-offs. When we use a higher confidence level, we are more sure that our interval contains the true population mean. But our interval would be larger than an interval we obtained using a lower confidence level. Larger standard deviations are directly proportional to larger margins of error because the data has more variability. We also have to consider sample size. Using a bigger sample size gives us a smaller confidence interval, but larger sample sizes are not always possible. Now let's take a look at Mr. Anderson's data.
Let's say we want a confidence level of 90% and a margin of error of 0.5 absences. We need to find the appropriate sample size. We can use our formula and plug in the values we know. From the data we obtained from Mr. Anderson's research, we know x bar is 5. A 90% confidence level gives us a z-star of 1.64. We will assume that the population standard deviation is 2 absences. Now we just have to solve for n. We get a sample size of 174.
In this video, we have learned how to construct a confidence interval.
First, 3 conditions of independent observations, normal distribution, and known standard deviation must be met. We also have to beware of outliers in the data.
We learned how to find z-stars so that we can use any confidence level we want, and we learned a general formula for calculating the confidence interval. However, higher confidence comes at a cost. Remember to always mention your interval or margin of error and confidence level in your conclusion. In the next video, you will learn about significant tests, another important tool in statistical inference. Until then, I gotta go help my daughter pick a present.